All right, guys. So this week is finals week, which is I know there'll be a lot of tests for you. So making sure you use your time well. Time management is going to be pretty important for getting all this stuff done. So first thing I want to show you is it's very possible. Okay, let me show you this. So you see how it says up here, this course associated grading period ends on November 20th. So that would be Friday, I believe, is November 20th. So let's say it's Saturday and you have to take a test, right? You will not, like, if you, this course will move around. You can still get to it, but it will move. It will become what it says archived. So if you need to find this page, and this goes for any of your classes that are using Schoology, it automatically gets sent away. So if you need to find this page, then to do that, I think you have to go to Courses, hit My Courses, and then it'll say like archives. See right here, current and archived. It'll be in the archive. You can still access everything, I believe. I'm pretty sure you can still see everything. You just have to click on archive to get there. Okay, so I wanted to say that in case I know there are some people who, I don't advise it, but you know, you got to live your life. So I know some people are doing stuff on Sunday night and Saturday night or whatever. So that's you probably have to find this. All right, so here's the problem. There are going to be two problems. Well, basically the same problem on the test. It'll be very similar, except it will be a different planet. So the acceleration due to gravity is going to be different. But I wanted to look at this because every problem we've done up until this point has been on Earth, but this one's going to be on Pluto. And there is a difference there, right? There's a difference in how we write those equations. So that's why I wanted to show you that. So here the scenario is your acceleration due to gravity on Pluto. That's what G, right? Acceleration due to gravity is G. It's simply how fast an object accelerates when you let go. Like if I let go of an object, it will accelerate. On Earth, it's 9.8 meters per second squared. On Pluto, it's much, much less. It's 0.62 meters per second squared because Pluto is so much smaller. Imagine NASA is going to test a new jetpack on Pluto. When worn by an astronaut, the jetpack shoots off with a velocity of 22 meters per second, angle of 70 degrees. Simply find the maximum height and the range for the astronaut wearing the backpack. So again, just like the problems we've done, but this time G is going to be different. So what I would encourage you to do is the first step is we got to be able to write those equations in motion. So I would encourage you to stop right here and simply see if you can write the equations in motion. So I'll give you a second, hopefully pause the video. You can stop and see if you're able to write those equations in motion, and then I'll write them and you can double check them. Okay, so I'm going to show you again. If you haven't, if you're watching the video and you haven't got it yet, make sure you pause and try to do it, because that's the best way to learn is by seeing where you messed up, if you mess up. All right, so here are the solutions I came up with, the equations I came up with, I should say. So first of all, what is different is G, right? G, we've been used to G being negative 9.8, but that's not the case here. G is something else. It's negative 0.62. Right, and I guess I didn't put that there. I should probably put that there. I'll make sure it's like that on the test, that it says negative. It is negative, sorry, because it always goes towards the ground, which again convention is we're saying down is negative. So negative 0.62. So the VYI part doesn't change at all. I did 22 times sine of 70, got 20.67. But again, the GT does, right? Instead of being at plus 9.8 t, or sorry, I guess it's becomes minus 9.8 t. It becomes minus 0.62 t. So already you can see, depending on how well your sense of this is, you can see this is going to be a very different scenario, right? I mean, normally this minus 9.8 t grows pretty quickly, but minus 0.62 t is not going to grow as fast. So when you toss something up in the air on Pluto, it's really going to go up in the air, which makes sense. If there's less, we think about gravity, we think of Pluto having less gravity. Well, that's why. The acceleration, because there's not less gravity, the acceleration due to gravity is going to be really small, and so some initial velocity is actually going to carry it pretty far. Okay, so then the other equation also, that last term changes. We get so used to writing minus 4.9 t squared, it gets really easy, but here it's not minus 4.9 t squared. It's still fairly simple. We just have to divide half of 0.62, which is 0.31. Again, that part doesn't change. There's no initial height. So my final answer is like 20.67 t minus 0.31 t squared. I'm not going to go over in too much detail the rest because it should be pretty straightforward, at least for the maximum height. I want to touch on something for the range. But anyways, for the maximum height, I'm going to, again, encourage you to pause the video, go ahead and calculate your maximum height, and then I will show you my solution as well, and you can check that from the maximum height. Okay, so you can pause the video right here. All right, I'm going to show you my solution now. Again, the very basic idea of maximum height we've gone over several times. The maximum height occurs when the vertical velocity is exactly equal to 0. So I took my vertical velocity equation, I substitute 0 in for Vy, and I simply want to solve for t. So that's what I add here. I just move negative 0.62 t to the other side, divide both sides by 0.62 to get t by itself. I get t equals 33.339 seconds. So that's when it's at the maximum height, right? That's when it occurs. But the actual maximum height, I simply take this time and substitute it into my height equation, the vertical displacement equation. So I put it into this right here, and that's what you see right there. And I kind of ran out of space, but you can see it. And I get for my final maximum height, 344.56. So I'm going to do the range in just a second. There's one thing I want to show you about range, but I'll give you a chance to. Okay, so again, you can hopefully pause the video if you need to. If you have questions, please ask about how I got that bug. Okay, let's talk about the range, because there's a little, I don't want to say trick, because it's just math, but there's a faster way you can figure this out, right? Because what you want to do when you're finding the range, right, you want to figure out when does the vertical displacement equation, right, when does this y equation, when does it equal 0, right? So really I'm saying I have, if I put in standard form, 0.31 t squared plus 20.67 t equals 0. I'm saying equals 0. So one way you can solve this is use a quadratic formula, right? A is negative 0.31, B is 20.67. That works perfectly fine. But because there is because there's not a constant term there, you can actually solve it a little bit faster if you simply you can pull out a t from both of these, right? So you get t times negative 0.31 t, because there's still one t left after I pull this out, plus 20.67, and that t is now gone. So I just pull the t out. You'll do this many times. Equals 0. And then you could say, okay, either t equals 0 is one of the solutions, not the solution we obviously care about, or, so right, these are two numbers here. Even though this is a really big way to write a number, it's still just a number, and t is a number. So in order for these two numbers to multiply, right, because we're going to multiply two numbers together, for them to be 0, either one of them has to be 0 or the other. That's the only way you can get 0 from multiplying two numbers. So either t equals 0 or negative 0.31 t plus 20.67 equals 0. You could actually solve it that way as well, and then you don't have to use a quadratic formula. Right, so I would subtract 20.67 on both sides, and then I have negative 20.67 minus, or divided by negative 0.31. For the time, I just get 66.68 seconds. Notice also, if you have written down your answer from the last one, on the last one I believe it was exactly half of that. So if there's no initial height there, then it works out that it's just like exactly halfway it's going to reach its maximum height, and so then if you double the time it gets to the maximum height, you find the time when it hits the ground. But that only works if there's no initial height. If there's initial height there, it kind of throws that parabola off a little bit. And so then that's the hard part, right? Getting that time is the hard part. The easiest part, the actual I'm going to try to say the actual range is quite simple. To find the range, we have to find the horizontal component, Vx. So off to the side, I'm just going to do 22 cosine 70. I got 7.52. So that's the horizontal component. So to find the range, I just take my velocity, my horizontal velocity. That's how fast it's going horizontally, and this is how long it's in the air. Just multiply those together. to get my range. And I get from my final answer 501.4 meters, which is a huge range. But again, that makes sense with what we see. If the gravity is really low, then this velocity, which is quite high, I mean, 22 meters per second is pretty fast. And that, you know, that's just going to take a long time for gravity to pull it down. So it's going to be up in the air for a very long time. And you see this, you know, if you look at like the moon landings, they did some videos where they like dropped certain items, like they dropped a hammer, and you can see that it just looks weird. It just defies kind of what we all kind of know about how things fall. We all know they fall at a certain rate, but then when you see it on the moon, it just it looks like it's in slow motion. And then on Pluto, of course, we've never been to Pluto, but if we went to Pluto, it would be even more. That would be exacerbated even more. It'd be huge. It would just like kind of float down, incredibly slow, and I think it would just really mess with our brains to see that. Okay, so like I said, there will be two problems. One asks you to find the maximum height, and one asks you to find the range on a different body other than Earth. So again, I'm really testing your ability to write these equations all the way from the beginning where you have a different value for G. Okay, so you can see information about the test. Test is on Schoology. You can see information on that checklist. Obviously, again, it's finals week, so I know your time is limited, so just make sure you are using your time well and asking questions if you have them. All right, thank you.